Next, we're going to go to still to zone. We're going to combine that with NAT to see the order of operation. That also got two questions in there about this. So what we're going to be doing now is the following. We have this interface to be inside NAT and this interface to be outside NAT. Now let's assume that PCA again runs that TFTP service. So PCA runs the TFTP service, and let's assume that that's a public service. I would want to provide internet connectivity with that service. What this means is that I want people from the internet to be able to connect in there and download something. Now the challenge is that this VNAT is not runnable on the internet, and because I want PCA to be publicly available at the same IP, it means I gotta go on router 1 and configure static NAT for PCA. So let's statically NAT 10.10.11.200, the current address of PCA, into via static NAT into 136.1.31.200. Let's initially do that static NAT. Let's confirm that PCA has the 200 address before IP config and has the 200 address. Let's go on router 1 and configure that static NAT statement. Conf T. I'm going to say IP NAT inside source static PCA to 136.1.31.200. Clear IP NAT translation. And let's make sure that before we do anything else, let's make sure that if I telnet from PCA, just a regular check to see that NAT properly works. From PCA out on the internet, I'm going to get NATed into that 136.1.31.200. Let's confirm that. So PCA, let's say telnet to 5553. Cisco, who? And I got NATed into the proper address as expected. So the static NAT works. So now what I want is, I want router 3 to be able to connect to that public service 136.1.31.200 in order to do a TFTP transfer. Now TFTP, as we saw yesterday, it's not a protocol like FTP, like SIP, like other protocols, which they have two types of sessions. A control plane session to negotiate back and forth how to speak TFTP, to authenticate the client to the server, and then the data plane session. So first of all, before we speak about TFTP, first of all, for the session to work, it means that we need a firewall policy in the direction of internet, because traffic that requests from the internet comes in on the internet zone interface and has to be routed out on the LAN interface. So we need a firewall policy flowing, with a firewall policy from the internet to the LAN, which allows that TFTP to work. So let's configure. We have now a firewall policy internet to LAN which just passes ICMP. That's not good. So we need to change that internet to LAN firewall policy to allow TFTP to work. And of course, I don't want to allow TFTP traffic from the internet to a destination in the LAN. I want to allow traffic from the internet to the LAN as TFTP only to that destination. So what we're going to do is, let's configure that step by step. So we have to build an ACL. There are a couple of ways to do this, but I'm going to make use of an ACL. I'm going to say IP access list extended. Let's name it TFTP from internet. And I want all traffic, I want to say permit IP any So any source from the internet. And the question, the big question mark is, what do I put as the destination? Do I put as the destination the mapped address of my the mapped address of my TFTP server, or do I put the real address of my TFTP server? And the answer is simple. It's a lot of similarities between the iOS zone-based policy firewall and the ASA firewall. So what I'm going to put in there is going to be the real address, 10.10.11.200. I'm going to explain why in a couple. And it's the same thing we're going to do in the ASA firewall with a new NAT configuration, which means after the H3 code. So if this was an ASA firewall, and I had to configure and I had to allow that traffic from the internet, so to flow low security level to high security level, with the new NAT configuration, which is after H3, I would have to do the same thing. On the destination, I would allow on the real address, not on the mapped address. So I'm going to say in here, permit IP any to host 10.10.11.200. So I want to allow all traffic from the internet, instance AIP, to that host. Now what do I do is the following. Class map. Of course, I could have said it, because TFTP makes use of 2 sessions, and I don't know what the ports are. It means I am going to do the configuration like this, permit IP host, I permit IP any from the internet to that host, my TFTP server. And I say class map, CMAP, TFTP. And I say match protocol. I say class map, CMAP, TFTP from internet. But this time I say I leave it the default of match all. Type inspect. Inspect. I leave it the default of type all because I'm going to say match protocol TFTP, TFTP, and match protocol, not match protocol, match address. And I forgot what's the name, what is the exact syntax. Let me paste this on router 1. As I said, I don't memorize commands, so some of them make sense. Some of them, like matching, is always a problem for me with Cisco because they always change the commands, like match address, match access group, match value, match name, match access group, name. Because they are not consistent and I don't memorize things, I never remember based on where do I have a match in a route map, in a class map of type inspector regular, what is the command saying that, because it's different. So what I'm saying with this configuration is that this class map means match all. So traffic is going to match on that class map only if IP source and destination matches on that ACL, which means any source from the internet destined to that host on the inside, and only if the protocol is TFTP. And then I go under my policy map from the internet to the LAN, and I say class, type inspect, this, and I say inspect. Because again, how TFTP works is that the client, this is my TFTP server PCA, and router is my client. Client is going to connect on the server on port UDP69 destination. Destination UDP69, source port random number. And then client, it's also going to initiate, that's the control plane session. This is the control plane session where the client authenticates. And then the transfer session is going to be another session, UDP session, on a random destination port number, which has been told by the server to the client in the control plane session. So in the control plane session, the server tells the client, connect to me for the transfer session on this port or on those ports. Okay, so let's make sure that I properly configure this. So I'm saying that permit IP to the real address of my TFTP server, not to the mapped one. Then I say class map match all, match TFTP, and match access group. And then class map type inspect, that's okay, and this one. So this should be good enough. Let's configure this now on router 1. Show policy map config, show policy firewall, not policy map, show policy firewall config, policy map. So pmap internet to LAN, class ICMP pass, and then class map cmap TFTP from internet inspect. And let's make sure that this class map show policy firewall config class map, the name, match on that match, it's a match all on that protocol and that access group. So now let's go on PCA, start a TFTP server, start TFTP server, then go on router 3 and connect for download, and we're going to look in the state table of router 1. So PCA, actually we're gonna do this example later on. Let's do, because I have the TFTP server on server A. So let's do this. Let's go in here, remove that config real fast. Show run policy map. I'm gonna do another thing. So let's quickly go LAN to internet to LAN. Let me quickly remove the config which I have done so far. So just remove that class map of TFTP from the internet. I'm gonna do this example later on, another use case, because it's gonna make much more sense in there. And of course, for the moment, let's remove that class map likewise real fast. Note this, and let's remove this ACL as well real fast. But still, to provide that, to show you that NAT configuration, how it works, let's do the following. Let's suppose that PCA, it is a telnet server. So it means we want to connect from router 3 from the internet to PCA on a telnet server. And likewise, as I stated, what I'm going to do is I'm going to allow session to go from the internet. And in my configuration, I'm going to match on the real address of PCA, not on the mapped address. That's like you would do in the on ASA above 8.3 code. So I'm going to rewrite this config as follows. I'm going to keep it for later, let's say configuration for later use cases. But for now, I'm going to name this ACL to be telnet from the internet. I'm going to leave the same configuration. Class map type inspect match all cmap telnet from the internet. Match protocol telnet. Match on that ACL. So it's an end between those two entries in the class map. I go in the policy map, which controls traffic from the internet to the LAN. And I call in now this class map called telnet from internet. And I say inspect. So let's paste in this config on router 1. So now let's telnet from router 3. 3 is gonna how this is gonna work is as follows. 3 is gonna build a packet source from router 3 with a TCP source random port number distant to the mapped address of PCA 136.1.31.200 on TCP destination port 23. The router receives the packet and first is going to do the destination NAT. So order of operation, this is my outside NAT interface. This is my outside NAT interface. Outside NAT interface. This is my inside NAT interface. So what a router does first as it receives the packet is going to first do the unnetting, change the destination. So it is going to unnet the destination to 10, 10, 11, 200. And then it's going to look, oh, okay, so now I know what is the real destination I'm trying to access. And then the router says the traffic came in on an interface which belongs to the internet zone. And traffic has to go out to that destination, which is routable on an interface which belongs to the LAN zone. So the router says now, do I have a firewall policy from the internet to the LAN which allows this traffic? And per my configuration, it is going to have, right? Because there we go. In here. The router says traffic flows from, let's put also the zone pair in there. So the router sees now traffic flowing from the internet to the LAN after it has done the NAT, the unnetting, the destination netting. And the router says, okay, what is the firewall policy for that source destination pair? It is that firewall policy, which it goes in there and says, okay, does that telnet traffic match this class map? It's not going to match it because it's of type ICMP. Does that telnet traffic match this class map? And it is going to match because it is a class map which says of type all, which says I want to match on this class map, traffic matches on that class map. If it's telnet, which it is, and if source destination matches on that ACL, which it does, because the firewall policy is inspected after the NAT has happened, and the traffic matches permit IP any, which is router 3, to host the real address of PCA. Which then router says, okay, because I match with this traffic on this class map, what does the class map tell me to do? Inspect. Which means that the router is going to allow the SYN packet to flow from the internet zone to the LAN zone. The SYN packet is going to put that entry in the state table, which means return traffic is going to be automatically allowed by the state table, SYN-ACK. And likewise, the ACK going out, likewise allowed by the state table. And then traffic is going to be allowed also to flow bidirectionally by the firewall state table because it has an entry in there. Now what I'm going to do, because PCA doesn't run a telnet service, what I'm going to do is I am going to kill temporarily this interface to show that the session is allowed to the firewall, but it's going to remain in the SYN wait state because PCA is not going to apply. So let me go and shut down temporarily PCA's link on the switch side. Or just put it in the wrong VLAN for temporarily. There we go. So now let's go from router 3 and try to telnet to PCA. Undebug all. Then we be prepared in here on router 1 to say show policy firewall session zone pair ZP from internet to LAN. We should see in there the traffic showing, the telnet session showing up. Telnet 136.1.31.200. Well, it doesn't work. So what we're gonna do is that 136.1.1.31.200. Let's make sure that that is the proper NAT address of PCA. Show up in NAT translations. Let's reconfigure let's verify the policy again. Show, so let's troubleshoot it. Let's say show policy firewall config zone pair from the internet to the LAN. So from the internet to the LAN, we state that if it's ICMP, pass it. If it's telnet and matches that ACL, and there we go, that's the problem. The ACL, I have used the old ACL, which was TFTP, which means my traffic has matched on the class default. So I had a typo in here where I used the wrong access group name of the ACL, which means, and it's good this happened because you see one more tissue ticket, which means the telnet packet going this way has matched on the class default with a drop action. Because this configuration also has in here a class default, put that in there with a drop action. So based on this config, traffic went from the LAN to the internet where this firewall policy is applied, and then I'm going to try to match that traffic of a telnet against the first class map. I'm not going to match this ICMP. Against the second class map, it's not going to match because in that class map, I say match all, which means for traffic to match on the class map has to be of type telnet, which it is, and match on that ACL, TFTP from the internet, which actually matches on the proper host. So it's interesting. Let's do a debug to see what happens. The first thing I'm doing here is, let's say, debug policy firewall, because my config seems to be good. Debug policy firewall protocol TCP, and telnet again from route fee. Show logging. So nothing seems to be built at all. 136.131.200, and let's make sure that is the translation version 136.131.200 for PCA. That is correct. Let's say clear policy firewall stats all, and also drop counters. And before we ping, we tell it again. Let's look on the counters of the firewall policy from the internet to the LAN to see we have no matches, no stats in there. So let's say show policy firewall stats zone pair ZP from internet to LAN. Let's say all. Not on route 2 and route 1, correct. Show policy firewall, show policy firewall stats all. And let's look on the under the internet, not LAN to internet, but internet to LAN. So internet to LAN for ICMP class map 0 packets, for CMAP telnet session 0 sessions, and for class map default 0. And now let's turn it again in the same direction, and let's see what the stats are showing in here to see if I'm matching any of my configured policies. And it looks like it's matching on a class default. So we have internet to LAN in here, and that telnet session didn't match on ICMP. That's correct, but also didn't match on my CMAP telnet, which it should have matched. Instead, it matched on a class default. So let's look again at the config. Show run section zone pair to make sure there are no typos in there, because it should have matched on zone pair. So this source internet destination LAN, I'm using this policy map as the firewall policy. Show run policy map, that policy map. ICMP I don't care, but this class map I do care. Show run class map, that class map, to see if I'm matching on my telnet traffic. And it's a match all with a match protocol telnet and match access group name this. Show IP access list that ACL, and there we go, it doesn't exist, right? So that's the problem. It was a misconfiguration, so we found out the problem was. And finally, let's say match access group name and put in there the proper ACL name, which was telnet from internet. And finally, now if you say show policy firewall config, not config, sessions, zone pair, ZP internet to LAN, and let's tell it again from router 3 now. Let's say show policy firewall stats again, all, because this time it should match properly. Internet to LAN. So internet to LAN, ICMP I don't care. It still didn't match in here. Well, because that's not interesting. I'm glad this happened. Because you have to be careful that when you match, because you can have multiple match statements in a class map. If something is wrong, you have to remove it and then put something else. So the problem here now was that I forgot to remove this, which again, it breaks my class map, because this means pretty much match any, because the ACL doesn't exist. Let's go in here and finally say no this. Let's go again at the class map, show run class map, which now matches on telnet and this ACL, which let's make sure it exists. Show IP access list, and it does exist. Okay, show policy firewall session zone pair ZP internet to LAN, and let's tell it again from router 3 now. And let's look in the there we go. Doesn't matter what the log message is, it worked. That's what I care. As I stated, router PCA doesn't really have a telnet service, but my configuration works because if you look in here, let's make sure tree has killed. It's gonna take 30 seconds for the send timeout. So let's wait for the session to die. There we go. But in the zone pair in here, the session was created. So I'm saying show policy firewall session zone pair ZP internet to LAN, so from the internet to the LAN. And my telnet session match on a class map telnet from internet in there. But of course it's embryonic because PCA is temporarily not available. So sent. So this confirmed that it works. And again, this makes sense. So if you have, as it was our use case, you have some service in there, a public service. So which is 10.10.11.200, which is known in the internet as 136.1.31.200, and you want to allow traffic to flow in from the internet to that public source, and you have static NAT in there and zone-based policy firewall. In your firewall configuration, you have to match on the real address, not on the mapped address. This is going to be the same thing if this was an ASA firewall, as you're going to see, with this being the outside interface and this being the inside interface. It's the same example that when you want to allow traffic from the internet to go on the inside, in the ACL, destination-wise, you match on the real address of the host, not on the mapped address in the newer NAT version. Okay, let's put back PCA in the network, switch 1, and let's make sure again that PCA can ping as the default gateway. And there you go, it works. Okay, so this was an interesting tissue ticket. So initially the problem was that the ACL didn't exist, which means it was behaving like a match anyway, which the class map was not matched. Then I added a new ACL, but I didn't remove the old one, which is a new tissue ticket, a good one, because you can have multiple mesh statements in a class map. It means that if something is invalid, the mesh statement, you have to remove it before you apply something else. It's not going to override the old one. And as you saw, my approach was very simple, right? I looked through the boxes constantly. So my approach was very simple and straightforward. Initially, I checked the zone pair to see what is the policy map which is applied. Then I checked the policy map to see what are the class maps applied and what are the actions for each class map. Third, I look in the class map to see what do I match on the class map. And initially, I didn't notice the problem because I didn't do also the last step 4, which means to check the ACL, and that was a problem because the ACL did not exist in there. So you see, if something breaks, you follow up on that approach as long as you know how things are being built, which means the firewall first looks okay. The traffic would go how? Internet to LAN. Okay, do I have a firewall policy in there? Internet to LAN, that direction. Yes, then what is the policy map? That one. Then what does that policy map tell me? Which class maps? On which class map does my traffic match? Then what is the action for that traffic type? So if you follow up on those boxes, on those blocks, you're gonna make it. You're gonna investigate. You're gonna pretty much, not in the end, but very fast, you're gonna be able to know what to spot a problem in there.